Okay, I think we're set to go. Welcome. I was asked by Justin to talk a bit about OpenShift and Omni. I asked him, what do you want me to talk about? And he said, well, you work with OpenShift, don't you? Can't you talk about your travels from OpenShift to Omni? We didn't really go to Omni, but I did look at the product itself. So I have some comments about that. But I'll mainly focus on OpenShift and what we did to reach Talos in the search for a secure and robust container technology distribution. My name outside of the Netherlands is Pip Omen. In the Netherlands, I'm called Pepijn. That's why my email address has my IJ name, the original Dutch name in it. I'm a platform engineer at Red Bull Inpro, and I recently got certified as a Kubestronaut by the CNCF, which gave me all those nice abbreviations down there. So who am I? I was born about 6 million seconds before Unix time existed or started, so it is actually a negative start number. My start location is Cincinnati, Ohio in the USA, actually. So I'm a US person, but I was born from Dutch parents, so I'm Dutch. But I live currently in Norway. It's the location of our office in Oslo. In the 90s, I was certified as an OS2 certified engineer by IBM. I was then certified by Lotus as a Node Domino professional, and then Lotus was bought by IBM. In 2016, I was certified by Red Hat as a certified engineer and an OpenShift specialist. And this was because they wanted a Red Hat instructor, so I was also certified by Red Hat as an instructor and an examinator. I traveled a bit around Europe to give OpenShift courses. Recently, I was, as I mentioned, certified as a CNCF Kubestronaut. I work at Red Bull Inpro. Red Bull Inpro is a company that was started out as Linpro in 1995. Red Pill started out in 2003 in Sweden. Linpro started in 1995 in Norway. We were Linux professionals, one of the first that were actually working with this. And in 2008, the Swedes bought the Norwegians, basically, because the Swedes had the money and the Norwegians didn't have that much money. The name was retained, and we're now known as Red Pill Linpro. We have offices through the Nordics. So if you look, this is Scandinavia. There's Norway, Sweden, and Denmark. And we have offices in Oslo, Stockholm, Karlstad, Linköping, it's really recently, Göteborg, Köpenhamn, Aarhus, and missing on the map, Trondheim. Was just established. I didn't get to update the map. What do we do? This is all the different areas that Red Bull Inpro is active in. We do IT management, we do API management, we do customer experiences. We do DevOps, which is consultants that work at the customers. We do integrations, security, red teaming, and blue teaming. We have digital workplace, which is stuff like Jitsi and RocketChat and MetaMost and LibreOffice, Nextcloud. So the open source variants of the usual automation packages for an office. We do development, a lot of Java development, some Python, data and analytics, and the last one, which I skipped over because that's the one I'm working, is cloud operations. We do basically the same as DevOps, but we do this from on office. But the two guys that are here from Red Bull Inpro are actually external consultants, much like the DevOps guys. So we help organizations to run their software in the cloud. We do have our own cloud, Red Bull Inpro Nordic Cloud, which consists of 3 data centers in Oslo, which runs OpenStack and OpenShift and Talos. We have a number of partnerships. The oldest one is Red Hat. Red Hat has been a consistent partner throughout the years because they also run open source as a philosophy. They figured out how to actually make money by running open source stuff. We have recently become a silver partner of the Cloud Native Computing Foundation, and we have strategic partnerships with Isovalent, which is now bought by Cisco, HashiCorp, which was now bought by IBM again, and Elastic, which just changed back to an open source license for their Elasticsearch product. By the way, Red Hat is also bought by IBM. So IBM is one of the words that you hear a lot during this presentation. In 2008, I started using containers for my private cloud. This was Linux containers. And this I did to simplify the running of multiple services. Those were previously run on separate virtual machines. But to make it easier to maintain those machines, I decided to run it on a single machine and have those machines in those services in separate containers. This is basically done by Linux containers, which uses namespaces, C groups, and which implies that we needed Linux kernel 2.6.24 and higher. It was a lightweight separation. It's by no means a really secure way of running things, but it separates things. So this is basically the start of where containers, as we know them today, started. On the side, there was Red Hat that provided OpenShift, and OpenShift was a way to enter the build, test, publish, scale market. Heroku was one of the first ones that was actually providing services like this. And this gave developers the opportunity to roll out applications in the cloud by just pointing at the repository. Here you have an application. This is my application that I want to run in the cloud. Make it so. Red Hat saw this as an interesting market and provided something that was called OpenShift. They started in 2011 and it was made available in 2012. This is basically the same as the previous slide, but now SA Linux was put in the mix. And this makes it a little bit more secure than the first one. So you actually had separation and you could actually run this as a multi-tenant service. And we did. At Red Bull Limpo, we started using production loads for our integration product on this first version of OpenShift. Note the terms gears and cartridges. So when I was starting out as an OpenShift trainer, I always mentioned that if you look for OpenShift on Google and you find gears and cartridges, you have the wrong version. But today, that's not really a problem because this is so old that the Google search engines don't really give those anymore. I actually had to have some make some effort to find what was it called again. It was gears and cartridges. In 2013, Docker came on the market, and this was basically Linux containers for developers. It did require privileged access. They did fix that by now, but at that point in time, it did require privileged access, and that means that it's inherently insecure. So this was not something that you want to do in operations. Further, I do not really like the concepts of Docker where you have a big blob, which does everything. So you had Docker build, Docker run for building and running containers, and Docker tag and Docker push for tagging and then pushing them to the cloud to be able to distribute the containers all within the same binary. As from Unix philosophy, we like pipes. We like to have small things that do actually that's what they do best, and you pipe those together. That's completely not what Docker does. I was in 2014 at DockerCon in Amsterdam, and I asked around, what about operations? And there was really no one who could answer that. There were some alternative ways of thinking about it, but at that point in time, there was not really an answer to how do we run Docker containers in an operations, in a scalable, in a high available way. There was CoreOS. CoreOS introduced Container Linux, and Container Linux is built on the the philosophies that Red Hat actually pioneered with Project Atomic. It was a single image operating system that used an AB for booting. So if you upgraded, you didn't upgrade your existing version, but you installed it in a different partition and then booted till that partition. We do that exactly in Talos as well. And it was meant to run only those things that you needed to run containers. It did provide, CoreOS was also the company that's behind etcd. It did have something called FleetD because it thought that we can use systemd as a mechanism to distribute loads, systemd units, over a fleet of machines. So they didn't call it a cluster, they called it a fleet. And that's what FleetD did. So it was a distributed systemd. And they came just in 2014, just before I went to Amsterdam, with Rocket RKT, which is in container runtime. Containerd, Cryo are the ones that we know today, but CoreOS came with Rocket at that point in time. It had a Tectonic installer, which gave us the possibility to have more advanced cloud init procedures. So when you boot your machine for the first time, you have cloud init, but cloud init is limited by its size of the initial scripts it could upload, and Tectonic uses Ignition to actually work around this limitation. So it looked very nice. I actually ran CoreOS for quite a while with Docker containers on it, distributed over a few machines to make sure that the Minecraft server of my son was always up and running. It used to crash, but it just took it up again in one of the machines that was available. So it was a good experience, and it was much more secure than the previous version used running in Docker, but we're not quite there yet. It made operating easier, but it still had SSH, and I could still do imperative changes on my operating system, which is something that you really should not be worried about. 2014, 10 years ago, we celebrated Kubernetes this year. Google came with Kubernetes, standing on the shoulders of Borg, a product that Google had in its own data centers, and they open sourced this product. It's not really this product as Kubernetes. Kubernetes in Greek comes from Greek. It means helmsman or pilot, and it is the root of the word cybernetics. This is something I just recently learned. I never thought about it. I think it's an interesting concept that Kubernetes actually is related to cybernetics. Since it was from Borg, and Google thought that Borg is not the nicest kind of species, for those who are familiar with Star Trek. There's one Borg actually that is a bit nicer Borg. This is 7 of 9. She's the tertiary adjunct of Unimatrix 01, also known as Annika Hansen when she was a little girl, and later became human again. The nod to 7 of 9 is in the spokes of the logo. There's actually 7 spokes. That's the reason why there's 7 spokes, because we want to have a nod to 7 of 9. Kubernetes, especially 10 years ago, great for running containers, distributed, but stateless. I was really not of the opinion that you should run any state within a Kubernetes cluster. This was something you shouldn't do. State has nothing to do in Kubernetes because of the way Kubernetes operates. And for security, it was really not secure at all, because it still used the same Docker as root concepts at that point in time. So it didn't really solve the security issues. For managing Kubernetes, you were still dependent on the operating system itself, because Kubernetes was just an application running on an operating system. Google developed the kubeadm, which in the beginning was really a sharp edges application. It has become much nicer, but you still need to run it on operating system, and the operating system needs to be updated. This is very visible in the Certified Kubernetes Security exam, where you have to upgrade the operating system that kubeadm is running on. Is there something I, as a Kubernetes administrator, am not interested in? It is administering an operating system. The operating system should just be minimal. Think Talos. And that makes it hard to actually have the complete experience for running Kubernetes. 2015, OpenShift 3. The initial version of OpenShift, OpenShift 1 and OpenShift 2, they were not based on Docker and Kubernetes as container technology. But Red Hat, as one of the early adopters of both Docker and Kubernetes, made an effort, and what Red Hat usually does is to make stuff enterprise ready. I think they did a good job on OpenShift 3. They made it secure by default. They had to focus on their previous customers, so they used the cartridges concept from OpenShift 2 and replace it with templates. This is something we don't find in Kubernetes anymore. I think we find it in OpenShift 4. Actually, I never bothered to look into that. The code came with deployment configs. Deployment config, not deployments, which is the concept from Gears. And they added something called security context constraints. This is the one that made users that came from Kubernetes to OpenShift most confused, because it does mean that containers cannot run as root, that containers are not allowed to do stuff which usually folk that came from a plain Kubernetes environment were not used to. Think change mod 777 as a way to fix problems. This was not allowed in OpenShift because OpenShift is secure by default. So you actually had to make an effort to make it your applications run in a secure way. They also provided role-based access control and users and groups. You could import users and groups from LDAP, have users signed against LDAP or other authentication systems. This has been, still is not really easy to do in regular Kubernetes. This become easier over time, but at that point in time, in 2015, this was something that Kubernetes just did not have. So what we got with OpenShift 3 is a secure, enterprise-ready Kubernetes distribution, using the regular technology that Kubernetes and Docker provided, but now in a way that you can actually run it as multi-tenant. Backdraw. Now, let's first talk about the other stuff that they added. Because they were coming from the Heroku OpenShift 2 model, they came up with source to image, which said, here you have a repository, give me a container image. Really cool technology with all its drawbacks as well, because it does automate things away. You have less control. But for someone who doesn't know about Dockerfile and Docker build stuff, source to image is really a nice technology. To support source to image, they also came with the build config and the image stream. It's really, image stream is also a nice abstraction away from how do you handle images from your Docker registries, container image registries, I should say. And of course, traffic had to come into the cluster. So they came up with the concept of routes and routers. In Kubernetes, we find those again as ingress and ingress controllers. So all those components that, lots of the components, not all, lots of the components that Red Hat added to the product later became adapted by Google and came back as deployments, ingress, role-based access control, users and groups. So there's not a single fork. It is not like OpenShift went one way and Kubernetes went the other way. It did have sort of a turnaround, which is always something I liked about the Kubernetes environment, that it's not going its own ways. OpenShift does have its own specialties, but they usually added those specialties that came from Google back into the base product. They also added a number of observability features during the years. Metrics were implemented through Cassandra, Heapster, Hawkler. This was before Prometheus was really a big thing. Logging was done through Elastic Fluent Kibana and not Logstash. At that point in time, everybody talked about Elk, but Red Hat decided that OpenShift should use Fluent instead. And at the end, they actually also added some operator like features in OpenShift 3.11. So the start of operators and Prometheus and Grafana is visible in the last version of OpenShift 3, OpenShift 3.11. It was sort of an idea about what the future might bring. The big challenge for OpenShift 3 is Ansible. It was deployed with Ansible on a basic operating system, and basically I chose CentOS 7 as its base operating system, but I had the same problems as with kubeadm. I had to have an active relationship with my operating system. I had to run yum update, yum upgrade, make sure that stuff doesn't break. If a certificate was expired, you had to run Ansible, and this easily could take half an hour. Adding a node took 2 hours. So this wasn't really the way I wanted to run a Kubernetes cluster. We were of the impression in Red Pill Linpro CloudOps that we could, in the initial phase, that we could just run multiple OpenShift clusters for multiple customers. But this didn't scale. OpenShift in itself is too complicated a product. It's not as complicated as OpenStack, don't get me wrong, but it's still a complicated product to do right over time. So the whole concept of running multiple installations of OpenShift basically fell down. So this wasn't really the way I wanted to run open container. I wanted to use container technology in our CloudOps operations division of Red Pill Linpro. And then Red Hat bought CoreOS. This was in January 2018. I do understand that Red Hat bought CoreOS, but CoreOS had those interesting features about the atomic upgrades of the operating system, the tectonic installer that gave interesting features. They did basically drop Fleet and Rocket. etcd was used by Kubernetes, so that was there anyways. But it did make sense that they bought it. And then IBM bought Red Hat. All of this led to... Not yet, because the first thing that's happened is that CoreOS was now not open sourced in the same way anymore. And to prevent any closed source environment, Kinvolk from Germany decided to release Flatcar as a fork of CoreOS. This is basically CoreOS in CoreOS Linux, container Linux, I should say. And they also used the tectonic installer, and they called it Locomotive. In 2021, Microsoft bought Kinvolk to also have a foot into the container technology framework. I thought that Flatcar looked very interesting. I wasn't that impressed with Locomotive. It didn't really give me anything. But I found Poseidon. Poseidon had a product called Typhoon, Poseidon Labs, which is a Terraform-based installer for CoreOS Flatcar-based Kubernetes product. It gives you the choice of a container network interface. And at my customer, we actually did blue-green because the documentation of Poseidon says we don't do upgrades. We do blue-green deployments. If you want to upgrade your Kubernetes, you install new cluster and then fail over your workloads to the new cluster. This was actually a nice thought, and at my customer, where I installed this in the first phase, we had our own fork with OpenStack, which I called Orkan, because Typhoon is the Middle East version of an Orkan. And a hurricane, it's in English. Orkan, it's in Norwegian, and Orkan in the Dutch. This is the European version of it. But I never released this as a public fork because the OpenStack configuration was really specific to our own OpenStack installation, so it didn't really make sense to provide this. I just combined the stuff that was in the Typhoon products from before. And we did do some blue-green upgrades. The reason we could do blue-green updates because the cluster itself was stateless. That's number one. The other thing that was important, that all the traffic from applications to other applications was through an API gateway. We use Varnish software. Varnish is a product that actually originated at Linpro in the beginning of the 2000s. So it made, and the customer uses Varnish Enterprise, something called Varnish Enterprise. All the traffic was going through Varnish Enterprise, and this gave us the opportunity to route traffic to the new cluster when we set up the new cluster. The Kubernetes configuration itself is stored in Git and kept in sync by using Argo CD. So we had stateless clusters that had configuration that came from a third party. And therefore we could actually use the blue-green upgrades. But over time, stuff was solved differently. Now we use inter-cluster communication, intra-cluster communication. So it's harder to actually route your traffic through a central external gateway. So the last versions, it's not really possible to do blue-green upgrades. But the big advantage of the blue-green upgrade, as I see it, and I still see it, is that I could switch out to CNI. I could switch out from CoreOS Flatcard to Talos. I wouldn't have been able to do it in the same flexible way if we hadn't had the blue-green upgrades. I must say that in one of the later releases last November, I actually took down all publications in Norway because there was a configuration error in the varnish layer, which led to the major other publications in Norway calling us and saying, what happened? Has Amedia been hacked? Because I made a configuration error. But stuff happens. Now we're thinking about how we're going to do this in the future. The reason I started looking at other stuff was not just because Red Hat bought CoreOS and ABM bought Red Hat, but because OpenShift 3 was basically frozen and OpenShift 4 was waiting to happen. They did finally release after a year OpenShift 4, but this was the commercial product OpenShift 4. It was a reworked OpenShift 3. It's based on Tectonic and CoreOS, which makes sense, and that's why it took time, because they had to redo everything again. It uses Terraform internally. It uses Cloud Provider and Cluster API as technologies, so they did focus on what's happening in the market, and they integrated all this stuff into the commercial product. It had a choice between installer provisioned infrastructure, IPI, and user provisioned infrastructure, UPI. And IPI is actually very cool, but our OpenStack product didn't support IPI because we had an old version of OpenStack. You needed a newer version of OpenStack. IPI makes the installer do everything because the infrastructure is actually provisioned by OpenShift installer itself. With UPI, me as an operator provisions the infrastructure and then install OpenShift on top of it. They did release an operator hub which has sanctioned operators for using in Red Hat. But what about OKD4? The other real problem with OpenShift is that it's a nice product, but it's big. It has a footprint that's enormous. It doesn't take so much time to install, but it is requiring a lot of hardware. And then you have nothing. You have a Kubernetes cluster, but that's it. OKD4 was forgotten. When 4.0 was released, I think for 1 or for 2, there came an excuse from Red Hat that they had been so occupied with reading about working with the integration of first CoreOS into Red Hat and then Red Hat into IBM, that they basically had forgotten that they had an open source product called OKD4 or OKD. So they had to work on releasing OKD4, and not before 4.5 in the summer of 2020, there was a release that was open sourced. They debranded the OpenShift Container Platform 4 product. So they took everything that said OCP and Red Hat and they took it away. It was based on Fedora CoreOS, called FCOS, which also was a process that they had to go through because there was no replacement for the commercial CoreOS product that was released by Red Hat. And to make things worse, now recently they decided to drop the FCOS and replace it with the CentOS Stream CoreOS. So we're waiting for OKD4 on the new version for 16. Real soon now there will be a viable way to upgrade from 4.15 to 4.16, while Red Hat itself has been on 4.16 with the commercial product for a while. So there is a number of, if you use OpenShift, if you have the money to buy Red Hat for OpenShift, it's a nice product, but it's big. It's better than what they had before because the direct relation to your operating system is gone. You do have CoreOS in the bottom, but CoreOS is still possible to do imperative changes. You can log in with SSH into the operating system and you can install stuff. I've experienced that with the OKD4 product where I had to fix things because there was an upgrade problem, and because I fixed it, I changed it, and therefore it was not like it was expected to be, and that made for a difficult upgrade later. So the imperative changes that you do to an operating system, which always complicates things, it's available in OKD4 or in OCP or OpenShift as a whole because of the way the operating system is treated. So that's why we're here. Talos OS fulfills a promise about how do we treat the operating system in the bottom. We have declarative operations. We love those from Kubernetes. I do. I love declarative operations from Kubernetes. It makes more predictable. It makes it easier to actually do blue-green stuff because you just recreate everything from scratch. But why limit this to applications? Why don't we always also do this on the operating system level? The hardest thing about introducing Talos into an organization that's used to doing stuff as they were before is, how do I log in to the host? The first question I get from my colleagues is, how do I SSH into this host that's now down? So you don't. Why? I need to log into the host. No, you don't need to log into the host. And then we need to explain how to do this. Well, there is, of course, the ways, but it does require a different mindset for the people that actually are operating the systems. We do provide the 24/7 service for on-call, but people that are used to doing stuff the old way have a problem with doing stuff the new way. We need to educate them. If you want to do multi-tenancy, because we do have an OpenShift installation that is multi-tenant, we have multiple customers within this system, the way out is using Omni. Because with Omni, you can just set up multiple clusters in an easy way. And multiple clusters, each customer then gets its own cluster. And there is a number of advantages of you doing it like this, because you separate a number of things. If you install a CRD into a cluster, it usually is cluster-wide available. And by having multiple clusters, you make it possible for customers to use their own CRDs within each. So hard separation that you use with Omni by using multiple clusters instead of having everything in a single cluster is simplified. The effect that we had earlier with having multiple OpenShift installations, that was sort of the background why we had multiple OpenShift installations. It's much easier to install a new cluster when using Omni. Cluster API is an alternative. You can use Cluster API, and if you're really hardcore Kubernetes and you understand your technology, it is a viable way. But Omni provides you with Cluster API for the masters. It takes away the edges of Cluster API and makes it really easy to install the cluster, new clusters using a single point of maintenance. And it can be done as a service, or you can install it on-prem. Here are some of the links and my LinkedIn profile, what I've been talking about. I hope there was something for everyone to learn. Thank you for your time. Questions? Yeah.
What's your 2024 view on statefulness within Kubernetes?
Containers for the win. Everything. I went to KubeCon in Paris. On the way there, I was discussing with a colleague. We were just thinking about the future. We now run OpenStack, Talos on OpenStack. Why don't we switch this? Why don't we run Talos or container operating system in the bottom and run KubeVirt on top? And if you run KubeVirt, then that says a lot about what you think about state. You do need to fix state, but state is basically disk. Where do you have your storage? And databases. Databases we have as a product, database as a service, so that has already been solved. A lot of the customer state was actually in databases. Then there's disks. What do you have as disk? And we do have Ceph as a solution on the outside as well. So the whole thing about 2014, you can't do state in Kubernetes, to 2024. There's really no reason to not have state in Kubernetes as well. I don't see any application that's not possible to do as a container. And if there's really something that stops you from doing it as a container, KubeVirt is probably the thing that could solve it, because there is an essential difference between containers and virtual machines. Containers are killed when it fits, and they should be able to be killed and not take down the application. Virtual machines, when you want to perform maintenance on a hypervisor, you want to migrate your virtual machine without taking it down, because they are much more sensitive for downtime. But that's basically an architectural decision of what you're running in your VM. So the best solution is to actually fix that, but that's a much longer road to usually, because that design that requires a architectural change instead of just running it as before. Yes, thank you. Ben, first.
Sorry, I'm just a little bit
Yeah.
late, but can I ask a question?
Yeah.
So how do you make the case for enterprise and corporate companies, customers, which are like mentally cultured and financially tied, locked into Red Hat operating systems to use Talos? How do you make the case for that? How do you approach it? Because they know, they say Talos is the best thing, but management, other people, I want to sleep good at night. I want to have the argument of I am safe because of legals. We don't take Talos. Maybe for internal purposes, but they're like, how do you make the case?
Not. I say we have the customer decides. It's hard to decide to convince the customer to do something else if they're not ready for it. There's an incentive of trying to save money, but legal is a problem. But you can buy support for Talos. So usually the issue is that people that ask questions like that want to have someone to blame when stuff fails. And then having a company like Red Hat with IBM taking the hit is much easier than a company like Sidero Labs. But as long as they can pay someone to fix their problems, then it doesn't really matter. So the major thing to focus on then is the difference in security. The whole thing about TPM availability of Talos and the sys PCI requirements make a hard case for using Talos for those cases where that's an issue. But in the end, if the customer says, I want Red Hat, then we say, okay, then you buy Red Hat. And we provide services on that. Thank you.